Hey everybody, welcome back to AP Stats. If you remember last time we were talking about how to display quantitative data, now we're going to talk about how to describe quantitative data. So the first thing that I would have you guys do normally is in your groups of 4, you would talk about how many colleges you were applying to. Since we have sophomores in the class, it's a little different, but it's the same idea. And so I'm going to go through some data that I got a couple years ago and show you how we go through and do this. So the first thing that we have you guys do is go through and, oh, by the way, I'm trying this where a lot more of this is filled out, so hopefully it'll be a little bit smoother. So let's say we had a group where we had 5 different colleges, 4 different colleges, 15 different colleges, 9 different colleges, and 6 different colleges. So you would go through and get all that set up, and then the first thing I ask you to do is calculate out the mean. And this is something the same way as you guys did back in middle school and elementary school and all that other stuff. Add them all up, divide by the number. So I'd add 5, 4, 15, 9, 6 together, and I got 7.6. And then from there, I would ask you, what's the range of the data? And the range of the data, again, is you can go 15 minus 4. Now, important point here, okay, range is a number. Okay, it is not an interval. Okay, so the range, you're not going to say, well, it's from 4 to 15. No, don't do that. The range is 11. Tells us how far, what's the distance between the smallest and the largest number are. It's hard to compare 2 ranges otherwise if we don't do that. Now, we're going to talk about something called standard deviation. Standard deviation measures how far away from the mean data is. So again, what you're going to end up doing is you're going to find the average distance the values away from the mean. So the first thing that we end up doing is this. So we put in all the values, and we talk about what the distance of the mean is. So what I did here was 5 minus 7.6, 4 minus 7.6, et cetera, get all that. There's another column that you'll probably see in the notes. It says we're squaring the distance. Here's my question. Why would we need to square the distance? There's a couple of different things, but if nothing else, it keeps everything positive. Because otherwise, what do you think all of these numbers would add up to be? Go through, if you have a second, and add up negative 2.6, negative 3.6, negative 7.4, 4, or 1.4, and negative 1.6. It'll be a pretty interesting number for you. So we go through and we square them. So we square it, we get an answer of 79 when we total all of that up. So the average you calculate is the average square distance of the mean. So we go down here, blah, 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 blah. So we took 79, we divided it through by 5. All right, cool. So now what we're going to do is we're going to go over to Staplet and make sure they have that up. And we're going to type in this data and see what they come up with for standard deviation. So quantitative single groups, variable name, colleges applied to. And only 5 pieces of data, 5, oops. 5, 4, 15, 9, 6. Get analysis. Boom. All right. So now notice here, they get their, apparently I typed things in wrong. All right, I'm back. I figured out my mistake. I accidentally typed in 14 instead of 15. So up here, we're going to go 14 colleges here. The range of the data here would actually be 10. So I've made these, I fixed my mistakes. Just gives you a more realistic classroom experience. So, I added all this up. I got 65.2. If I divide 65.2 by 5, I get 13.02. Great. So we completed the table. So the average you calculated is the average of the squared distances. So how would we find out what the average distance was? Okay. So, square root, yay! So we're going to do square root of 13.02. And that would be 3.6. And we'll just keep it at 1 down, 3.61. Let's go 2 decimal places. So we're going to go stat plot and enter the data in the classroom and check out the summary statistics. So same thing as before. I fix this now. And their mean right here. I forgot to change over. There we go. So type this in, blah, 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 blah. Looks good. Make sure I didn't make many mistakes in the data. So mean 7.6, check. Minimum for N is 5. Wait a second. Standard deviation there is 4.037. Okay. So the question then becomes, what happened? Why is it different than the one that we got? Well, I will show you. So standard deviation of, the standard deviation that we found, which is 3.61, is smaller than the standard deviation in Statplet. Which was, what did we say, 4.037. So 4.04. Now, we forgot to add me. I applied to 20 colleges. So we're going to add that to the data set. And the question then is, what's going to be the new mean? Blah, 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 blah. So what we're going to end up doing is this. Let's go back here for a second. So the original so we've got what? Mean and standard deviation. Let's go median first. So the original mean and median standard mean is 7.6. Median was 6. Standard deviation is 4.04. Our new one, if I come back up here and add in a 20, is my mean now is 9.667. My median is now 7.5. And my standard deviation is now 6.218. Okay, so the question is, how does it compare? Okay, so the new mean, median, and standard deviation all increased from the original value. So why is it? Well, here, let me show you. If we go back, let's say I change that 20 to, I don't know, something just crazy. Okay, so let's say that we had one of your groups. So let's go back here. So let's say your group of 14 was actually a group of 30. First of all, here, let's see the original analysis. So the median is 5.5. Oops, nope. Keep it at 14. Okay, so you got the median 6, right? Boom. 2 pieces of data to the left, 2 pieces of data to the right. Now, if that 14 would change to, let's say, 34, okay, redo it. Notice the median still says 6. I still have 2 pieces to the left and 2 pieces to the right. The difference, however, is the fact that this outlier has gone from 14 to, or the endpoint goes from 14 to 34. So if we look at this, the mean has changed, the standard deviation has changed, the median hasn't changed. We keep all the data points the same. So with that being said, if we keep that the same, so if one data point changes, the median stays the same. Because again, median, remember, you talked about where in the order you are, not necessarily where, or, you know, so you're not changing the value of it. We're going to come back to this here in a second, but for now, let's talk about what we got. So actually, you know what, I'm going to do it this way. Now, what ends up happening is this. First of all, let's talk about what's happening here with the standard deviations, okay? Here, we're going to end up dividing by n minus 1, not n. N is the number of pieces of data that we have, right? And I'll show you why. Think about everybody's thing that they hate growing up. Schoolyard pick, right? So if I've got numbers, actually here, so let's say we've got students A, B, C, D, E, F, right? And so this is team number 1. This is team number 2. Okay? The n minus 1 is called degrees of freedom. And the reason why we call it degrees of freedom is like, how much choice do you have in what's going on? So for example, actually, give me 1 second, I'm going to pause this. I think I thought of even a better way of doing this. All right, here we go. So the reason why we go by n minus 1 and divide not by n is the following. Let's say you're sorting things out into 2 different groups. So I pick A, and I put them over here. And we pick D and put it over in this group. And then I pick C, and I go over here. They pick B, put it over here. Now here comes the interesting thing. At the end, I'm actually making decisions for both teams, or both groups. Why? Because if I pick E, does this group have freedom of choice of who they pick last? No. By picking E, I'm also giving them F. I'm forcing it upon them. Likewise, if I pick F to go over here, E has to go over here because that's the only option for them to pick. So the question is, when you're doing this, how many items out of the 6 do you have a free choice on? First person who picks can pick any of them. Great. Second person who picks can pick any of them. So that's 2. Third person who picks can pick any of them. That's 3. The 4th pick can pick any of them. So now we're up to 4. The 5th pick can pick either of those. That's 5. But now the last pick has to pick that last person. Okay, and because of that, that's called degrees of freedom. And that's why we have this, n minus 1. We divide by n minus 1 because if we don't do that, we're not taking into account that the last one. Because the sum has to be, in our case, 65.2. So when I do all of these numbers here, when I get to the last number, so if I'm adding all these up, let's say we knew that the sum was 65.2. When I add 6.76 and blah, 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 when I get to the last number, it has to be 2.56. That's the only way I can get up to that number. If any of these numbers change, it's going to force that last number to change. So, in fact, here, there's my original data right there, right? So if I take 65.2 and divide that through by 4 this time, I get 16.3, and the square root of 16.3 is 4.04. And that's why it works. Okay? Your standard deviation formula here is basically this. Okay? Standard deviation is going to be equal to the square root of the sum of the differences between the data. So x sub I minus x bar squared. What this little I down here does is the index, and what it does is tells you where in your list you are. So like this would be n sub 1, n sub 2, n sub 3, n sub 4, n sub 5. It just tells you where in the list of numbers you are. And you're going to divide that through by n minus 1. Okay? The other thing to remember here is that mean and standard deviation are not resistant to outliers. Remember when we changed that one number from 14 to 34? The median stayed the same, everything else blew up. And if you think about it, it makes sense. Median is a place where you are in order of line. The other two are calculated by the values in that list. Okay?